Hello everyone. So today we would be solving Leetcode 1514 path with maximum probability. In this problem, we would be given an undirected graph having edges and success probability. So given two nodes start and end, we have to find the path with maximum probability of success to go from start to end and return its success probability. And if there is no path from start to end, we simply return 0. For example, what is the minimum probability of going from start, which is equals to 0, to end, which is equals to 2? So either we could take this path from 0 to 2 and incur a probability of 0.2, or we could go from path 0 to 1 and 1 to 2 and have probability equals to 0.5 into 0.5, as the probabilities are multiplied, so it will be 0.25. So greater probability is 0.25, hence our answer is 0.25. Similarly, if we try run here, the path from 0 to 2, direct path, is 0.3 probability, and the indirect path would take 0.25 probability, so we return the greater probability, which is 0.3. Here, the start is 0 and end is 2. As you can see, this is not a connected graph, hence there is no way we can reach from 0 to 2. Hence we output 0. So there is no path from 0 to 2. So when we read this question, uh, uh, what is it that strikes your mind? So we have done similar questions in Dijkstra's. So in Dijkstra's algorithm, what do we do? We have the question of maximum path sum from A to B. If you think this question is similar, but it differs from Dijkstra's in two ways. So in Dijkstra, we find minimum path sum from A to B. Yeah, so this question is similar to Dijkstra, but with two minor changes. What are those changes? In Dijkstra, we use minimum path. So we use minimum priority queue. So here, instead of minimum priority queue, we need maximum priority queue, because we have to find the path with the maximum probability. And second difference would be, we used to find path sum. Here, instead of just path sum, we are finding product, because we are dealing with probabilities here. So it's just a simple modification of Dijkstra's algorithm. Uh, so let us try run Dijkstra's once before we start coding. So yeah, here I've taken one of the examples which were given. So let us dry run it first before we code. So this is our node 0, 1, 2. We have start node equals to 0 and end node is 2. Right now, our maximum priority queue is empty. And let us initialize the probability initially as 0, 0, and 0. So since our start node is 0, we will input uh, uh, 0, and the probability of reaching 0 is 1. And initially also, in the probability of start node, will initialize it as 1. So let us begin our Dijkstra's algorithm. This is our maximum priority queue, so this will get popped. Let me write here. We are storing probability comma node. Yeah, so we just popped out 1 comma 0. So going to the adjacent nodes of 0, we'll have 1 and 2. So 0 to 1, the probability is 0.5. So since it's greater than 0, we uh, increase the probability of 1 as 0.5, and going from 0 to 2, our probability is 0.3. So we'll edit 0.3 and put both of those in our priority queue. So in our priority queue, higher value would be first, which would be pop, so 0.5, and my node is 1. Here 0.3 and my node is 2, right? In the second iteration, what we do, we pop this value out. So we just popped out 1. So we go to their adjacent nodes. So once adjacent node is 0, 0 already has a probability which is greater than 0.5, so we would not edit it. From 1 to 2, the probability is 0.5. So we are at 0.5 currently, and we have to go to 2. So that would be 0.5 into 0.5, which is 0.25, which is less than 0.3. So we would not edit it. So since we have not performed any additions, we would not add anything in the maximum priority queue. We'll pop this out of the priority queue. 0.3, we just popped out 2. So going from 2 to 0 is 0.3, which is less than 1. So we do not edit here. And going from 2 to 1 is 0.5. Um, uh, Going from 2 to 1, yes, it's 0.5. And we do not edit here since zero point 0.5 is greater than 0.015, right? So yeah, so finally we return the probability of n node, which is 0.3, which is our answer. So let us code it. So we'll take maximum priority queue. So prior priority queue pair of double, because we're dealing with probabilities, and int, which will denote my node priority queue. What else do we need? We'll need a vectors to store all the probabilities. So vector in probabilities and n comma 0. So as I said, in pq we'll push 1 and the start node, and in probability of start node we make it as 1 because we are already at the start node. So we'll keep popping out from the till the priority queue is not empty. So in probability would be how much pq dot top dot front first, then in node would be pq dot top dot second, then we'll do pq dot pop. After that we'll have to iterate to the children, right? So for auto I, we'll make it as double. Yeah, so for auto I in adjacency of node, so if the probability of I, we'll have to make adjacency list as well, but our adjacency list would contain node and the success probability. So I dot first, if the probability of I dot first is less than that of the probability that of reaching that node, multiplied by I dot second, we'll just update probability of I dot first as probability into I dot second. This is simple Dijkstra, and insert it in the priority queue again. Yeah, so simply we're done. And just we return the probability of n node, but we haven't made the adjacency list, so let's make it vector in adjacency of n. So let us not take int, it's a pair of int and double. So for int I equals to 0, I less than edges dot size I plus plus. So what would we store? Since it's an undirected graph, we'll have to store both the values. So adjacency of edges I 0 dot pushback what edges I 1 comma success probability of I. Similarly, uh, the other way around. Yeah, so we've made the adjacency list as well. It contains a pair of int and double, which will denote a edge. For example, if we have an edge A to B, it's not a directed graph, it's A to B, and it has a success probability of 0.3 in adjacency list. How we would store is A goes to b comma 0.3 as well as b goes to a comma 0.3. So we would be able to access both a and b as it is an undirected graph. So let's see if it runs. Yeah, seems. Mm, okay, it's start underscore node and n underscore node. Mm, um, wait, are we? Oh yeah, so it'll take double, right? Yeah, so it's passing here. Let us submit. Yes, it's accepted solution. Thank you.